Hi friends, today let's learn about Williamson's synthesis. Williamson's synthesis is the preparation of ether. Ethers are the organic compounds with the general representation ROR. An alkyl group, for example CH3, then an oxygen atom and with another alkyl group. So it can be same alkyl group or it can be different alkyl group like CH3, O, C2H5. So the first one is a symmetrical ether and the second one is an unsymmetrical ether. So anyway, the oxygen atom is joined with two different alkyl groups are called the ethers. And today let's study about the Williamson synthesis to prepare ethers. So ethers are prepared from alkyl halide RX. RX is alkyl halide is on reaction with sodium alkoxide. Sodium alkoxide is RONA. So during the reaction, I'll explain how the mechanism during the reaction. During the reaction, as we know that sodium alkoxide is having an oxygen atom. It is electron rich, it's a nucleophilic center. So this electron pairs will be donated to the carbon atom of alkyl halide. As a result, this oxygen atom is connected with the alkyl group. It means you are going to be getting a product like this, ROR, that is this. So this X eliminated with this Na as NaX. So it means the alkyl group combines with the oxygen and alkyl group of sodium alkoxide. For example, if you take CH3Br and CH3ONA, when you take a compound, two compounds like this, CH3Br and CH3ONA, this NaBr gets eliminated and we are joining the alkyl group of CH3Br and then OCH3. So this is how we are getting. This is called a methoxymethane. So it can be like any other alkyl group. If I am taking like C2H5Br plus CH3ONA, then we are going to be getting like C2H5OCH3. It means the sodium and bromine atom will be liberating as NaBr. So that's a byproduct. As a result, these two alkyl and alkoxide group will be joining together. We are getting an ether. So the reaction is so simple. When you are getting an alkyl halide and sodium alkoxide, this is how we can join. But 2 3 points you have to memorize while doing the reaction. That is, the alkyl halide RX. Always the alkyl halide should be primary. It means if you are taking a secondary alkyl halide or a tertiary alkyl halide, you are not going to get an ether. Ether formation won't be taking place if it is secondary or tertiary alkyl halide. But if it is primary alkyl halide, you will be getting ether. But if it is sodium alkoxide, it can be anything like primary, secondary or tertiary. No matter, we'll be able to prepare ether. So when you select the reaction or when you get a product to write the reactants, you have to select always the reactants with alkyl halide with primary alkyl group. So here is an example. CH3 thrice CONA. So this is alkoxide RONA and this CH3 thrice C is called a tertiary group. We know that CH3, that I'll write it here, CH3 thrice C. CH3 thrice C is tertiary, CH3 twice CH is secondary and CH3 CH2 is primary. This is how we know that the primary, secondary and tertiary alkyl halide. So here the sodium alkoxide is a tertiary group and CH3Br is a methyl group only, methyl bromide only. It's not even a primary as well, it's just methyl bromide. So during the reaction, this NaBr gets eliminated. As a result, these two alkoxide group and this alkyl group just join. We are getting an ether like this. CH3 thrice, this becomes like CH3 thrice C, then OCH3. So that's a product. This is how we are writing the product. But just opposite case if you are taking. Instead of like primary or methyl halide, I'm taking a tertiary group like CH3, C, CH3, CH3. This is tertiary. Tertiary with the halogen atom. So in the previous reaction, the tertiary group is with the sodium alkoxide part. Now the tertiary group is with the halogen atom and the other one is CH3ONA, sodium methoxide. In this case, how the elimination is taking place, the sodium as usual eliminated with Br as NaBr. That's one of the byproduct. Now one another byproduct is this CH3O accept one hydrogen atom or one H plus ion from the tertiary group. So one hydrogen is coming towards this oxygen atom and forms CH3OH. Plus the main product is after the removal of this hydrogen atom, we are getting a double bond between this carbon and the CH2. So we get CH3, C, CH3, double bond CH2. It means the product is an alkene. In which case we are getting a product as an alkene. When the alkyl halide is tertiary or secondary, we get the product as an alkene. We are not going to get either if it is tertiary or secondary. That's the important point. Now why? Why we are getting this? What's the reason behind this? So normally in the previous reaction, as I told you, when we take an alkyl halide and sodium alkoxide, always this oxygen of sodium alkoxide is having electron rich or electron richness is there, electron density is over there. That electron is donating to the alkyl group. That's what we can call it as a nucleophile. The sodium alkoxide is always acting as a nucleophile. But there are two roles for sodium alkoxide. Number one is it's of course it's a nucleophile. That's what this oxygen atom, which oxygen atom? This oxygen atom of sodium alkoxide is losing electron to the alkyl group of alkyl halide. Of course it's nucleophile. The second reason is it is acting as a base. There are different definitions of base. We know that. One of the famous definition is a base is a species which are ready to accept proton or H plus. So in this reaction, it's clear that the CH3O, it's a nucleophilic part. This O is attracting one hydrogen from this alkyl halide because it's acting as a base, a strong base. Because of that nature, it accepts a proton so that the main product we are getting as an alkene. Got it? So this is one of the reasoning question normally in all the CPSC board exams and all. It's there is a chance for coming this kind of question. Why we are getting an alkene if the alkyl halide of Williamson's synthesis is tertiary or secondary instead of an ether? Why? Because alkyl halide combines with the sodium alkoxide. Sodium alkoxide as acting as a nucleophile as well as a base, a strong base. So I have written the same reaction here once more. So I hope you understood. Let's do 2-3 questions to understand the concept a little more in a better way. You see there is a reaction like C2H5ONA plus CH3 thrice CCl. Here we identify this is alkyl halide. This alkyl halide is tertiary. And this is sodium alkoxide which is RONA and that is primary. What do you think? We will get the product as ether like this? No, of course we don't know. We will not get it. Why? Because tertiary alkyl halide, we will not get the ether product. We will get only alkene. So the question number one is what would be the major product of this reaction? It is an alkene. So that alkene will be like this. This Na and the sodium chloride, sodium chloride will be leaving. That's one of the product, byproduct. And the CH3O accept one hydrogen from here. So C2H5ONA plus as a result the CH changes to CH2 here, CH2 double bond. It means CH3, CH3. Any one alkyl group you can do like this. Double bond CH2. So this is the major product. The alkene is a major product. And the name of this alkene is 2-bromopropene. So this chain we can take. 2-bromopropene is a major product. Now write the suitable reaction for the preparation of tertiary butyl ethyl ether. Tertiary butyl means CH3 thrice C. This is tertiary butyl. Ethyl is C2H5. Ether, of course, we have to connect it with oxygen atom. So to prepare this ether, which alkyl halide and alkoxide, sodium alkoxide to be taken, that we have to select according to the nature of alkyl group. So the left side you can see it's a tertiary. So always tertiary you connect with the sodium alkoxide. So CH3 thrice CONA. Always with the sodium alkoxide you write the tertiary alkyl group. And with the C2H5, that is primary, so that is with the bromine atom. So C2H5 bromine. So this is how if you are writing the reaction, we will get an ether. So I hope you got the point. Next, some products are given. Let's find the reactants. Let's start with the simple questions like 1-propoxypropane. Propoxy means CH3, CH2, CH2. This is propyl. That's connected with the oxygen atom is propoxy. And then propane is CH2, CH2, CH3. So to prepare this, as we know that the both the sides like left side and right side, both are primary only, CH2, CH2 only. Both are primary. So that there is no confusion in this question. We can write CH3, CH2, CH2, Br plus CH3, CH2, CH2, ONA. Like that we can write sodium alkoxide or bromine to any of the alkyl part. Now ethoxybenzene. Ethoxybenzene is benzene with the C2H5 but oxygen because it's ethoxy, C2H5. We can write as CH2, CH3. Got it? So this is ethoxybenzene. And in this case, we have to see which is primary and which is secondary, or any tertiary is there or not. CH2, this part is primary. So that of course it should be connected with the bromine atom or the halogen atom. And when you take this particular carbon atom is secondary. Why? Because there is a hydrogen atom. It's tertiary, sorry, it's tertiary. There is no hydrogen atom. 1, 2, 3, 4, all four valencies are satisfied. So it can be connected with sodium alkoxide. So benzene, you take and you connect it with the sodium alkoxide, and the other one like CH3, CH2. That ethyl group you connected with the bromine atom. Got it? Next, number 3, methoxy, 2-methoxy, 2-methyl propane. So propane, first of all we will write 2-methyl propane. 2-methoxy means OCH3. This is methoxy. Then 2-methyl. 2-methyl is 1, 2, 3. If you write in this way like CH3, CH3, this is propane. And in the second position 2-methyl. You see this? So if I'm taking this as the main chain, here number 1, this is 2 and this is number 3. In the second position 2 methoxy group is there, and also in the second position methyl group is there. So this is how we can make it. And now we are going to decide which is the part which is going to be added to the bromine and with the sodium alkoxide. Always you select the carbon which is attached directly with the oxygen atom. So this carbon and this carbon number 2 you have to select. Carbon number 2 is of course it's a tertiary. So that tertiary you go with sodium alkoxide. So that is CH3, CH3, CH3 with ONA. We can write like this. And the other one like CH3 you have to write along with the bromine atom or the halogen atom. Now 1-methoxyethane. Methoxy. Methoxy is again OCH3 is methoxy. Ethane is CH2, CH3. Here of course CH3 Br we can write and CH3 CH2 ON. So there is no much difference in this because it's methyl and primary, there is no much difference. So the questions can come like by giving the reaction they can ask whether it is correct or not, or from the reaction what is a major product, or to get a particular ether what can be the reactants, or from the products they can ask to write the reactants. So when you write the reactants, make sure that you are not going to be chosen secondary or tertiary for alkyl halide. Or it can be asked even like a conversion, for example like phenol to anisole. So let's draw the structure first. Phenol is benzene with OH. Anisole we know that benzene with the OCH3. So OCH3 means it's an ether. So when you apply Williamson's, this is like Rx plus RONA to prepare ROR. We need an alkyl halide and sodium alkoxide. But the given compound phenol is not one among this. It's something different. It's not an alkyl halide, it's not a sodium alkoxide as well. So from this we need to prepare something like which has a bromine atom Something like that we can prepare. But if we go for like preparing bromine, for example, by adding like nucleophilic substitution reaction, like HBr, if you're adding, we get bromobenzene. But the problem is this carbon is a tertiary carbon. So with this, we will not get the ether. So that this part, it means the phenol part or the benzene part should go along with the sodium to prepare sodium alkoxide. So the best method is you add sodium. So you will get sodium phenoxide. It is tertiary, but doesn't matter. To that you are adding, it means in our hand this RONA part is ready. Now we need this RX part. This R group is depending upon the R which is present in our product, that is CH3. So to this you add CH3Br. So now the sodium and bromine will be leaving as NaBr. So the CH3 gets attached with the oxygen atom as benzene with OCH3. So this is how we can prepare and so. So you have to listen to the question. If it is like either preparation, somehow we have to apply Williamson's synthesis over there. But the given compounds are not like RX or RONA. From that given compound, you have to change it into RX and RONA and then join. Okay, so you have to learn the topics in this way so the questions will be really helpful. Thank you all.